Okay, so we have two functions left to look at. The first one is going to be the cubic function, and that's because the x value, or variable, I'm sorry, has a cube power of 3. And so that's the parent function right there, and we can see this. And if we were to make a little table right here with our x and y values, so if you plug in 0, well, 0 to the third power is just 0. 1 to the third power, if you plug in a 1, you'd have 1 to the third power, which is 1. If you plug in 2, you'd have 2 to the third power, which is 2 times 2 times 2, which is 8. And that starts to go off of my picture here. Your graphs on your homework will be a little bit bigger, so you'll probably see that point. And then if you go in the negative direction, so if you do a negative 1, what happens is you have negative 1 to the third power, which is negative 1 times negative 1 times negative 1. So the first negatives multiplied together will give you a positive, but then when you multiply that by the last negative 1, it turns into a negative 1 as your result right there. So these are the three key points we're going to use right here that I'm highlighting. So negative 1, negative 1, 0, 0, and then 1, 1. But I just wanted you to see how fast it accelerates once you go past that. So once you go to 2, it jumps all the way to 8. Or negative 2 would jump all the way to negative 8. All right, but we're just going to use those three key points to move it around and then just kind of do a rough sketch here. So the transformations, the rules still stay the same on how that works. So looking at our first one right here, we have g of x equals negative x cubed minus 3. So that's going to cause us to shift down 3. So I'm going to go ahead. There's my original 3 key points right there. And then they're all going to shift down 1, 2, 3, 1, 2, 3, 1, 2, 3. Now, the way you want to draw this is it's kind of like a skinny parabola opening up on one side and a skinny parabola opening down on the other side. So that's kind of the shape it takes right there. Okay, on 97, the difference is we have the minus 3 directly with the x before the exponent is applied. So that's going to cause us to shift to the right. We're going to go to the right 3 spots. So there's our original points that we start out with. Then we're going to move them all to the right. 1, 2, 3, 1, 2, 3, 1, 2, 3. And then that little skinny parabola going up, a little skinny parabola going down. There we go. Okay, on 99, we have a negative out in front right here. Oops. Sorry about that. My screen went blank there for a moment. Okay, so we have a negative out front right here. And so what that is it's negative 1 times x cubed. So the negative is getting applied after we cube it. Okay, and so that's going to cause a reflection across the x-axis. So across x-axis. Okay, so we'll put our 3 key points here, and then we're going to reflect them across the x-axis. So this is going to flip up. The 0, 0 just is going to stay right there, and then that one will flip down. And so now when I draw this, the parabola is going to be opening up to the left and opening down to the right, like that. Okay, let's see, moving on, I just have 2 more of this type. So on 101, we have a 1/2 in front. Once again, that 1/2 is getting applied after the power. And so that's, our results, the y values are getting cut in half. And that's basically what we're going to do. We're going to multiply y by 1/2. Okay. So here are my key points. And I'm actually going to go ahead. Let's see. 2, 8 would be up here, and -2, -8 would be somewhere about here. It's a little off my graph. And the reason I'm using those points is because this thing's going to condense horizontally. And so all these y values are getting multiplied by a half. So this gets cut in half, and this gets cut in half, and then when y is 0, that just stays right there. And that's fine. I could draw it with these 3 points, but I'm going to go ahead and cut these other ones in half. It's just going to help me draw my picture a little bit more accurately. And then let's see, at -2, that -8 gets cut in half to -4. Okay, so what that's going to do is it's going to cause it to open up a little bit wider. So I'm going to open up a little bit wider. Still goes up really fast, and then to the left it still goes down really fast, but just kind of goes at a little bit of a wider pace right there. Okay, alrighty, and then our last one, let's see, so we have 2 transformations. The first one's going to be right 2, okay, and then up 1. So we'll put our 3 key points here. And so let's see, go right 2, up 1, right 2, up 1, right 2, and then up 1. So there's my 3 points. And then we draw 1/2 opening up and 1/2 opening down. Okay, so that's our cubic function. The last one we're going to look at is going to be a cube root. Okay, so it's going to be pretty similar to the square root function, except that it does go left and right indefinitely. Okay, so if we go back to our square root function, we just went out to the right and the parent function right here because we can't square root negative numbers, right? Can't square root negative numbers. Well, cube roots, you can square root negative number, or you can cube root negative numbers, so we include those. So here's the parent function. You can see, once again, I kind of, in this example, it goes a little bit further out. It goes out to 8, 2, because if you cube root 8, that would equal 2, okay? The way cube roots work is you're trying to figure out what value to the third power gives you what's inside that radical sign. So 2 to the third power gives you 8. So that's why the cube root of 8 is 2. Same thing with -8. So the cube root of -8 equals -2, because if you do -2 times -2 times -2, it would equal -8. And so that's all cube roots are. So we could use those points right there, but our graphs aren't going to be quite that big on our notes. So we're going to use this. We're actually going to end up using the same exact 3 points that we did for the cubic function. So if we go back to the cubic function, it's going to be the same 3 values, but they look they look kind of similar, but they're very different. One spikes up, and then the others are going to go really fast to the right and to the left, right? So it's just kind of like your cube root function turned on its side, okay? And so once again, when you kind of draw this, you kind of draw that kind of parabola type curve to it. It's just that they're going to be going in different directions. Okay, so let's go ahead and try this. So remember, we're going to use those same 3 diagonal points, but then it's more of like the square root function type curve. All right, so on this first one, we have +2, and it's on the outside, so it's going to be up 2. So let's see, here's our 3 key points, and then we'll go ahead and just move them up 2, up 2, up 2. And then when we draw this will curve like this, and then this one will have the same type of curve, but down and to the left, like that. Okay, our next one, the +2, is inside, so that's actually going to cause us to go left 2. So we'll take those 3 points and move them to the left 2. And then once again, try to draw this best we can. There we are, and then curve this one down like that. All right, on our next one, we have quite a few transformations going on here. So we always have to start out with the horizontal first. So that's going to cause us to go right 2. And then vertical is always last, so we're going to look at the 1/2 next. So you're plugging in x, and you're multiplying, you cube root it, and your result, your y value is getting multiplied by 1/2. So that's what we're going to say. Multiply y by 1/2. What's happening is it's condensing vertically, but I think it's just kind of easier to look at it that way. As far as describing your transformation algebraically. Okay, so then last part is we have the +2, which is going to cause us to go up 2. So we put our original points there. And once again, this thing's going to kind of become a little tight here, so I could add some extra points if I wanted to, but I don't think I will. We'll just stick with these 3. So let's see, I'm going to go to the right, 1, 2. My y value goes from being -1 to a -0.5, and then I have to go up 2. So from -0.5, I go to +0.5, and then +1.5. So that's where that first point went. So I went to the right 2. The y value gets multiplied by 1/2, so y was -1, so now it becomes a -0.5. Then I add 2 to 0.5, which would take me to 1.5. Then my next point, I move to the right 2. My y value is 0, so multiplying by 1/2 doesn't do anything, and then go up 2, so I'll end up right here. And then let's see, we'll go to the right 2. My y value gets multiplied by 1/2, so it goes from +1 to +0.5. And then I'll go up 1, 2 spots right there. So this one's going to be a little tricky to draw. It's probably not going to look all that great, but I'll do the best I can. So you want to kind of have some curve to it the best I can. But that, yeah, see, that's pretty messy, but it's really hard to do on this computer, especially. All right. So let's see. Let's go ahead and look at our last one. So the last one, let's see, I have 2 transformations. The first one's going to be left 2, and then I have the negative out in front, okay? And so basically that's going to be a reflection across the x-axis, or you could say multiply y by -1. It accomplishes the same thing. The description of the transformations that it reflects, but you can just say the algebraic description is basically multiply y by -1, which will cause that reflection. Okay, so we'll put those 3 points right here. So we're going to go left 2, so let's see, 1, 2, and then multiply y by -1, so I reflect across. And then let's see, left 1, 2. My y value is 0, so multiplying by -1 doesn't change anything. And then let's see, left 1, 2. Multiply y by -1, so I reflect across, so I end up right there on one of those original points. Okay, so then when I draw this, when I go to the right, it's going to go down like that. And when I go to the left, it's going to go up like that. Okay, so yeah, transformations, that was, that took 3 videos to complete all those, so it's a lot. It takes time to kind of really get a good grasp of it, so don't be discouraged, just keep working at it, and I'm sure we'll get there.